Let's find the limit as x and y approach 0, 0 of x minus 4y over 6y plus 7x. Okay, for this we're going to approach 0 from x and y. So let's say x approaches 0. So we'll have 0 for x and then we'll have y. And so for every x we're going to substitute it with 0. So it'll be negative 4y over 6y, and that simplifies to negative 2 over 3. Now if we let y go to 0, we'll have x comma 0 approaching 0, 0. And here y is going to be 0, so we'll have x over 7x, and so the limit is 1 over 7. So in two different paths, we were able to find two different limits, and thus we say the limit does not exist. Next example, we have the limit as x and y both approach 0, 0. X squared minus y to the 6th all over x times y cubed. So here I'm thinking it's probably not going to exist, the limit, so I want to look at two different paths, and the key here is to look at the exponent. The largest exponent in the numerator is a 6, so what can I do so that the other two terms are also y to the 6th? Well, that means x has to approach y cubed. Okay, so we're going to replace x with y cubed. Now we'll have y cubed squared is y to the 6th, and then the bottom it's y cubed times y cubed, which again is y to the 6th. But notice the top we have 0, and so the limit here has to go to 0. Now let's take another path. What if x approaches y? So if y going to 0, 0, and so instead of x squared we'll have y squared, and the bottom will just be y to the 4th. So this reduces into a limit just y approaching 0, and I can factor out a y squared and be left with 1 minus y to the 4th over y to the 4th, and this is just 1 minus y to the 4th over y squared. And here you can think of a function 1 minus y to the 4th over y squared as just a function where the vertical asymptote is at 0, x equals 0, and as y approaches positive infinity, this will go to negative infinity, and it's also going to negative infinity as y approaches negative infinity. And let's say if we pick y equals 1, that's going to be the x-intercept. And as y approaches 0, we basically have 1 over 0, so that's going to infinity. So, and we're also going to have another x-intercept at x equals negative 1. So it should look something like this. And clearly this is going to go to infinity. So one path took us to 0, the other path took us to infinity, therefore we say the limit does not exist. Okay, last problem, we have the limit as x and y approach 2, 1, x squared minus 2xy over x squared minus 4y squared. For this, let's factor out the top. We notice we have a factor of x in both of these. So that's x times x minus 2y. And the denominator we have a difference of 2 squares. So that factors into x minus 2y, x plus 2y. And now the x minus 2y's are going to cancel. I can plug in x equals 2 and y equals 1 to get 2 over 4, which is 1/2. And that's our answer.